Upasona Panday. I'm a first Prof Medicos from NILRATAN SIRCAR Medical College and Hospital. So in this video, I have discussed about the continued portion of the generation and the conduction of the nerve impulse. I have mainly discussed about the action potential, the graph of the action potential and the structural aspect of the synapse. Hope you enjoy the video and watch the full video. Like, share, comment, and also you can join our Instagram and Telegram. The links are provided in the description. Chalo, start karte hain video. In the last video, we have already started our discussion on the generation and the conduction of the nerve impulse. We have already talked about the resting membrane potential, the action potential, the conduction of impulse in a single neuron. Now the impulse has to be transmitted from one neuron to the other. Why? Because the impulse has to be sent to the processing units of the human neural system, that is the central nervous system. There it is processed and the response is sent to the effector organs. For that, there should be transmission of the impulse. That is done by the synapse. There comes the role of the synapse. We will discuss in detail about the synapse, the structure of the synapse, the role of the synapse, and the mechanism of the transmission of the impulse. But before that, we need to go back to where we have left in the previous video, that is the graph of the action potential. Okay? Let us recall the terms once again. The resting membrane potential, what is that? That is the potential difference across the axonal membrane that arises due to the various ionic activities present on the axonal membrane. What is action potential? The action potential includes all the events that starts with the application of the stimulus, then the generation of the impulse, the conduction of the impulse throughout the nervous system in an undiminished manner. Okay, and the conduction of impulse in the axon that we have already seen, right? Now we need to look into this graph. The resting membrane potential, the value of resting membrane potential is minus 70 millivolt in case of the neuron. You see, minus 70 millivolt. Now, what happens? First of all, the stimulus is applied. Then the sodium ion channels open and there is the influx of the sodium ions inside the cell. But my friend, let me tell you one thing, that at the initial phases, this entry of sodium ions is not rapid. Only a few sodium ions enter because only a few sodium ion channels open. And there is a slight increase in the positivity of the axonal membrane. Okay? But that is countered by the exit of the potassium ions from the cell. So there is repeated depolarization and repolarization occurring on the axonal membrane. And this continued depolarization and repolarization work to give plus 15 millivolt of potential to the axonal membrane, so that the axonal membrane reaches minus 55 millivolt of potential. Why minus 55 millivolt of potential? Why I am stressing here? Because this is the firing potential. This is the minimum potential for the action potential to begin. This is the threshold potential that should be given for the initiation of the action potential. Okay? Now we have given this minus 55 millivolt of potential to the cell. Now the potential is, it has reached the firing potential. Now what will happen? Now all the sodium ion channels, all the voltage gated sodium ion channels will open and there will be rapid influx of the sodium ions inside the cell. That increases the potential to almost plus 30 millivolt. Okay? You see that this is given around plus 30, but we consider this to be plus 35. And this depolarization occurs within a very short span of time, so that the graph is almost vertical. The graph is almost vertical for depolarization, you see, because there is rapid influx of sodium ions inside the cell. And as we have already learned that the sodium ion channels remain open for very short period of time. When this potential reaches plus 35 millivolt, then all the sodium ion channels closes. At the same time, the potassium ion channels open up and there is the exit of the potassium ions from the cell. This marks the repolarization. Why? Because initially at resting membrane potential the membrane was polarized and the influx of the sodium ions inside the cell has depolarized the membrane. Now it has to be repolarized. That is done by the exit of the potassium ions from the cell. Okay. Now at the initial phases of repolarization, the efflux of the potassium ions is very rapid. But at the later stages, this becomes quite slow in comparison to the previous phase, so that the graph of the action potential, the graph of the repolarization is almost vertical at the initial phase and then it becomes quite slanting, which is not very clear from this diagram. I'm sorry I could not bring you a good diagram, but this is almost like this. Okay, you see. This is almost like this. Okay. Now, unlike the sodium ion channels, the potassium ion channels remain open for a longer period of time. So, even after the membrane reaches is minus 70 millivolt of potential, then also the potassium ions continue to leave the cell. That makes the potential even more negative to minus 70 millivolt, and that phase is known as the hyperpolarization. Okay, so we are clear with this. You should be learning along with the video. So may I repeat once more? The influx of the sodium ions, then the depolarization, then the closing of the sodium ion channels, opening of the potassium ion channels, then the repolarization, then hyperpolarization. You see, it reaches even below minus 70 millivolt. This is hyperpolarization. So the graph is somewhat like this. I am over marking on it. Okay. It is somewhat like this. Okay. So we are done with this graph. Now we will move to our topic of discussion, that is the transmission of impulse. That is the conduction of impulse from one neuron to the other. Okay. We'll look into the synapse because this synapse helps in this transmission of the impulse. So this is a schematic diagram showing the synapse. This is the terminal branches of the axon. This is synaptic knob, right? This is synaptic knob. These are the synaptic vesicles, and these pink dots are referred to the neurotransmitters. And let us discuss the structure of the synapse. This synapse is composed by a presynaptic membrane. You see, this is the presynaptic membrane. This is synaptic cleft and a postsynaptic membrane. This presynaptic membrane and postsynaptic membrane has different functions, and then functions determine their structures. So what is the function of the presynaptic membrane? Its function is to release the neurotransmitters so that the impulse is being carried by the neurotransmitter and that reaches the postsynaptic membrane and the impulse is transmitted to the postsynaptic neuron. So this presynaptic membrane has thickened areas. Those are known as the active zones. Where the synaptic vesicles fuse and the exocytosis of the synaptic vesicles occur to release the neurotransmitters. Am I clear with that? Okay. Now, this is synaptic cleft, you see. The synaptic cleft is the gap between the presynaptic membrane and the postsynaptic membrane from where the neurotransmitters travel. And what is the function of this postsynaptic membrane? Its function is to catch the neurotransmitters. So it should have some receptors. You see this orange color receptors? These receptors accept the neurotransmitters so that the impulse, the information carried by the neurotransmitter transmits the impulse to the postsynaptic neuron. So this is the basic structure. Okay. Now we'll discuss about the neurotransmitters. What is the definition of neurotransmitter? The neurotransmitter are the chemical substances that are released from the presynaptic membrane by the exocytosis of the synaptic vesicles into the synaptic cleft. From there, those are received by the receptors present in the postsynaptic membrane, and the impulse is carried by the neurotransmitters. Okay. Now there are two types of neurotransmitter. One is the excitatory and the other one is the inhibitory. Why excitatory? Now when these neurotransmitters are released, then they set the cell into action. They excite the cell to perform something. And what is inhibitory? Now this will inhibit the cell from doing a particular function. Here are the examples. Excitatory, for excitatory, the acetylcholine, epinephrine, norepinephrine and glutamate. And for inhibitory, the dopamine and GABA. Now let me confuse you a bit. We know about the parasympathetic system. What is the neurotransmitter for parasympathetic system? As per I remember, this is acetylcholine, right? And what is the function of the parasympathetic system? Its function is to inhibit the performance of the heart muscles. Not inhibit, then we will die. Really not inhibition. To reduce the performance of the heart muscles so that the heartbeat reduces. It reduces the force of contraction of the heart muscles. Right? The cardiac muscle. But this is the excitatory neurotransmitter. What is this? How is it happening? This is happening because our neurotransmitter is excitatory or inhibitory based on the receptors which accept the neurotransmitter. Our neurotransmitter can be inhibitory as well as can be excitatory. But we have marked this differentiation based on the fact that these two neurotransmitters usually function as inhibitory neurotransmitter, and these four usually function as the excitatory. Most of their functions are related to excite the cell, and most of the function of this inhibitory is to inhibit the cell from doing any activity. Okay, now let me clear your confusion. I have made a confusion, right? So this acetylcholine, when this acts on the skeletal muscles, when these are secreted by the neuron that excite the stimulates the skeletal muscles, there what happens? Now it excites the skeletal muscles to contract. It sets the skeletal muscles into contraction. That is, it acts as the excitatory neurotransmitter in case of the skeletal muscle. But when it acts on the cardiac muscle, the receptors are different, and the different receptors make this acetylcholine an inhibitory neurotransmitter for the cardiac muscles, and this reduces the heartbeat. That is what is the function of the parasympathetic system, right? So I think we are done with this neurotransmitter. Okay, now we will go into the types of synapse. There are two types of synapse. One is the electrical synapse and the other one is the chemical synapse. What is this electrical synapse? In the electrical synapse, the presynaptic membrane and the postsynaptic membrane are approximated to each other so that the gap between them is very small. The synaptic cleft is very narrow. So the impulse can jump from the presynaptic membrane to the postsynaptic membrane, and the conduction of impulse, the transmission of impulse is similar to the conduction of impulse in axon fiber. There is no complication about this electrical synapse. And what happens in this chemical synapse? In this chemical synapse, this presynaptic membrane and the postsynaptic membrane are not approximated. There is a wide gap of synaptic cleft. Here, the neurotransmitters are engaged for the transmission of the impulse. Neurotransmitters are mandatory to carry the impulse. Otherwise, there will be no conduction. If the neurotransmitters are not present, then the impulse cannot jump from the presynaptic to the postsynaptic because of the gap. So, the neurotransmitters acts as the bridge between the presynaptic and postsynaptic in case of a chemical synapse. So, we can understand this. Electrical synapse is a bit faster process. So, where it should be present? It should be present in the most advanced part of the human neural system, that is the cerebral cortex. And this chemical synapse is basically present in the peripheral nervous system and also some parts of the central nervous system. Okay, so we are done with the synapse. Now we will discuss the transmission of impulse. This is a schematic diagram showing, but I think I am making the video too long. So I will discuss from this transmission of the impulse in the next video. Okay, bye-bye. Thank you for watching the video. Leave some comments so that I can understand that I can teaching somebody, or it feels like I am just speaking in front of the camera. It will make me more comfortable. Leave some comments, like the video and subscribe the channel if you are new. Bye bye.